In this unit, we're going to study the factored form of a quadratic function. The factored form actually looks like this. I'm just going to write it straight out here. Y equals x minus p times x minus q. So there, you've got two factors there and a leading coefficient function. Now, I do this slightly different from other teachers. Basically, I primarily focus on the trial and error method when I factor the quadratic expressions. So let's look at this. I'm going to demonstrate how to do this. Basically, my focus is to factor the first term and then factor the last constant term in this example. And somehow I manipulated, I want to come out with the exact term right in the middle. So how do I do that? What I do is I factor the first term vertically. X squared can be rewritten as x times x, right? And 12, how can I break up 12 and somehow have a 7? So there's a pair of factor that's 3 times 4. That looks pretty good to me. So I write it out vertically as well. And now I cross multiply. I should have 4x plus 3x. And magically, I have my middle term. And if it matches, that means my factors are right there. My answer to this one is x plus 3 times x plus 4. It's that easy. It's staring right at you. So I really like this method. I don't teach any other methods. Over the years, I've learned other teachers using sometimes housing method, sometimes box method, diamond method, and then they have to pay attention to the leading coefficient. In my case, the leading coefficient is an invisible 1, right? And with this method, it doesn't differentiate. One method kills it all. All right, guys? Now, during exams, during practices, I often skip the double check step, which is not a great habit. But during exams, if you want to double check whether this is correct or not, you can simply use distributive property and write it back to, I have x squared plus 4 squared plus 3 plus 4x plus 3x plus 3 times 4 is 12. So that should give me x squared plus 12x plus 12. Matches my original expression. Okay. Now, I'm going to give you something a little bit tricky on this side. I'm going to do it here. How do you factor something like this? Difference of squares. If you recognize that you can use this directly from the difference of square formula, you can do that. Oops, that's a B. Sorry about that. But if you don't remember that, what you do is that you don't have the term in the middle, right? The x term is not there. X squared is there and minus 9 is there. So in order to forge this to become a null term, I use a 0 multiplied by x. Now I do my factoring. X squared is x times x. Negative 9, how do I make that somehow split apart? 3 times negative 3 is 9, and then the sum of that is 0. So when you factor it, you keep an eye on this pair, and somehow that sum has to hopefully yield the middle term. And now if you cross multiply, you have negative 3x plus 3x equals 0, or 0 times x, right? So now, like I said, your factors are staring right at you. So that's a somewhat cumbersome way of doing difference of squares, but it proves that property pretty easily. Relate factors to zeros of a function. So we're given this function y equals x squared plus 2x minus 8. And I put the graph there. And it's asking how do the zeros of the function relate to the factors. So let's factor it first. If I have x squared plus 2x minus 8, and if I factor both terms, where do I place the negative sign? 2 times negative 2 gives me negative 8. So that's how I prove my factors now are x plus 4 times x minus 2. That's my function there. Now, in this case, I know my x-intercept. X-intercept happens when y equals 0. So if I set y equals 0, I solve this based on zero product property. X equals negative 4 and x equals 2. At these 2 points, my function is 0, right? So as you can tell, this demonstrated that the factors x plus 2 and x minus 2 are related to the two zeros. So what I mean is right here, my factors right here, x minus 2 and x plus 4, are related to these two solutions or these two zeros, since each of the zeros makes one of the factors 0. That's how they're related. Zero product property, I love it because it helps with cancellation so much. It states that if a product of real number factors is 0, then at least one of the factors must be 0. So if I express it, that means if A times B equals 0, so I can do if, then either A equals 0 or B equals 0. So that means for this type of function, or equation, you're gonna have to have two answers in this example. If I have A times B times C, then you're gonna have three options there. Another quick example, this time, obviously the constant term is on the other side. Doesn't really matter. Feel very comfortable of switching them around. And then after that, it's the same deal. Factor the first term. Probably 6 and 7 would give me, yield me a 1 with the difference. So I put the negative sign, I put it on the 6. You can put it on the 7, but you're not going to come up with a middle term. You're going to have the opposite. Cross multiply, and I get my middle term. My factors are right there. So I rewrote the equation into factored form. Now, based on zero product property, I know that at 6 or negative 7, that's when my my equation equals 0. That's my, 6 or negative 7 are my zeros. In this whole chapter of quadratic equations, you're going to find a lot of similar problems where a ball is thrown from a certain height or a diver flies out of the diving board at a certain height. And they have a lot of similarities because they form a quadratic function with a parabola shape, right? So let's look at this. A multi-level driving range has 3 levels. Marco hits golf balls from the second level, which is 32 feet high. The height of a ball x seconds after Marco hits it is modeled by this function h of x, which is height of x, equals negative 16x squared plus 16x plus 32. When does the ball hit the ground? So a couple of keywords here. First of all, x seconds. So we know this x, the input, must be time. And secondly, we were already told that h is the height. And thirdly, we're asking when. So we're asking for the x value, right? So if I have to graph this out, which is always highly recommended, I'm going to graph it on the side here. If I have a coordinate plane and the travel pattern of this ball is something like this. So if this y-axis is height, 0 is the ground. The y-intercept would be 32 feet high. So this is the height, right? For x is my t, my time. So this parabola describes a relationship, obviously, I'm not doing this right, between height and time. Now what it's asking is, given this function, h of x equals negative 16x squared plus 16x plus 32. If it travels with this shape, and when the ball hits the ground, meaning when h of x equals 0, what is my x value? What's my t value right here? So it's really solving for the equation here. So let's try that. Negative 16x squared plus 16x plus 32. We already said that at 0 height, right? 0 feet. What is the value of x here? So if I factor out negative 16, I should have positive x squared minus 2x plus minus 2 now equals 0. And I'm going to erase this a little bit just to make it easier. If you factor this, you should have x plus 1 times x minus 2. Just do my vertical factoring approach. And then at x equals negative 1 and x equals 2, that's meant when my y is 0. Now, because we're being asked for time, obviously time has to be positive. I wish time had a negative so that I can grow backwards, right? So therefore, this answer has to be crossed out. The final answer is x equals 2. So you have to write it out that after 2 seconds, the golf ball hits the ground. So this would be 1 second. This would be 2 seconds. So write down after 2 seconds, the ball hits the ground. So again, a quick recap. Anytime you see a problem that's throwing a ball, throwing a diver's body off the diving board, throwing anything off of a certain height, set up a quadratic equation. The y-intercept is the initial height, and then figure out which one is the x-axis, which one is the y-axis, how they're connected, and solve for it. Okay? Determine positive or negative intervals. Identify the intervals on which the function y equals x squared minus 2x minus 3 is positive. First of all, if I want to find intervals, I know my function is intersecting with the x-axis. In the back of your mind, you should have this diagram roughly drawn already. And if you have this drawn, you know exactly what you're looking for, which is these 2 points, the 2 zeros, right? So in this case, I let y equals 0. I said y equals 0, and then I solve for x. And then the 2 solutions are my zeros on the x-axis. So at x equals 3 and x equals negative 1 are my 2 solutions. But also notice that these 2 points cuts that function into 3 intervals. So now I have one interval is x is less than negative 1, and one is between negative 1 and 3, and one is greater than 3, right? So graphically, you observe it, you should know the answers already. But algebraically, you have to demonstrate it. Why, when x is less than 1, the function is positive. So you just basically grab a number that's less than negative 1. So I'm going to let x equals negative 3. I plug it into my original function, negative 3 squared minus 2 times negative 3 minus 3. Be mindful of all of that negative signs, my final answer is y equals 12. So when x equals negative 3, y equals negative 12. From the diagram, it verifies that. And in this case, my function is positive, right? And also at this point, reflect upon this. I want you to understand the relationship. The sign of the y value of the test point at x equals negative 3 is the same for the y value of any of other points over the entire interval. So as long as it's when x equals negative 1, for any value that satisfies that, then the y would be completely positive as we see on the diagram. Now let's do an example between negative 1 and 3. I'm going to let x equals 1. So let x equals 1. And if I solve the function, I plug it in, my y come out to be negative 4. And therefore, this is negative. Again, in that same interval, one test point is negative, the entire interval is negative. And this is really easy, actually. It gets easier, right? If I plug in 6, you can do 5, you can do whatever. My y would equal positive 21. So those are my 3 scenarios. Verify that with the diagram in those 3 intervals. Double check it, and you will see that this is the correct answer. So finally, here is a quick review or recap of the concept in this unit. Here again, the standard form of a quadratic equation is here, and this is the factored form, right? P and Q are the zeros, and they're the x-intercepts of the graph corresponding to the zeros of the function. And these 2 zeros cut the function into 3 intervals, and parts of it will be increasing, parts of it will be decreasing. In order to test that, all you need to do is to pick one testing point within each interval, plug it into the equation, and then whatever the result comes out, if it's positive, that in that interval the function is positive. Very straightforward, but you can have quite a bit of fun trying to solve different kind of puzzles. All right, guys, good job.